Hi, I'm Benedict Kiprono. I would like to take you through the earthquake alarm system. So this is the earthquake alarm system that I had mentioned the other time, and it has four main components. The first one here is the ESP32 microcontroller board. You can have a view on that. Yeah, there it goes. As you can see, it has a lot of ports, cables connected to it. I'll dive into that soon. It also has the vibration sensor, which detects vibrations, that have surpassed a predefined threshold, which now the vibrations will be earthquakes, right? So long as they have surpassed the predefined threshold. Then we have the red LED. There you can get that, the one that has like a red bulb. That's now the red LED. What it does, it usually sounds the alarm, a visual alarm, when the predefined threshold has been surpassed, meaning that there is an earthquake. Then we have the P buzzer, the fourth component here, which sounds an alarm now in terms of sound, not light like the red LED. Those are the four components. I can start by how they function so that you can understand. The first thing that usually happens, of course, I'll have to connect power to this because it's not functioning because there's no power. That's the first place. After connecting power, then the vibration sensor, which I've noted that it's this, which is at the top there. What it does, it detects now the vibrations. After that, that's why it's actually connected. As you can see, there's this cable that goes to the ESP32 microcontroller board, where the information gathered in the vibration sensor, it now goes to the ESP32 microcontroller, because that is now the brain of this whole thing. So the information goes there. It has surpassed a certain threshold. Then this decides what to do by now sending the alarm, so that somebody, you can know what to do if there is an earthquake. So it will now process that information and send instructions. As you can see, there are two cables that are going. Let's just follow them. So one of them is from both of these components. So the first one, you have the P buzzer, where it sounds now, it gives a sound warning. Then the red LED, which now gives the light warning. So that's basically how it works. When the predefined threshold is surpassed for the vibrations, that means that it is an earthquake. Then this will sound by giving both a visual and sound warning. I can now demonstrate how that works in real life. So let me power it on, then you see what happens. First of all, before I make any connections, I can explain something. For this system to work, for even the brain to work, it needs to be programmed, right? That's why we now need to connect it to a computer where code has been written. So I can take you through that a little bit. We have a USB cable, which is a type C actually. Then there it is. So it's usually connected to the microcontroller board, and what it does, for this cable, it transmits both signals and electricity. Signals in the sense of the instructions as code to the microcontroller, and also power in terms of electricity. That's what it does. And it's connected to the microcontroller board, as I've mentioned. So here is the port where it is usually connected. Let me show you that. So there it is. As you can see, it is a type C port. That's where it's connected. So what we did with the code is we've simulated that the vibrations have surpassed the predefined threshold. So when I now connect it, this USB cable there, that means that the red light will be on and the sound will, you'll be hearing the sound. Yeah, so let me now do that. Yeah, so the first thing in the microcontroller board, you can notice that there is a light somewhere. That means that power is there and it's working. So let's go here, because here is where we can get everything. As you can see, the red LED, it's lighting, and the P buzzer, it now gives that sound. Yeah, that's how it actually works. When there is an earthquake, it will signal you that way by the sound and the light as well. Thank you. Subscribe for more. Don't forget to like, share and comment. Yeah, have a nice time ahead, and don't hesitate to join the AI and robotics club. You're welcome. You can just share your details in the comment section, and we can add you to the club. Yeah, have a nice time. Bye.